morning, students. So we have already completed all the discrete probability distributions, that is Bernoulli distribution, binomial distribution, Poisson distribution and hypergeometric distribution. Okay, so we have completed that. So as I said, in continuous distribution we have three important distributions, that is normal distribution, chi-square distribution and student-density distribution, correct? No. So in that normal distribution is already started. So in today's class I'll start with the second continuous probability distribution, that is chi-square distribution. Okay, this chi-square distribution is denoted in a notation this chi-square, two cross lines. Okay, the chi-square, the rotation. Okay, so first, before studying this chi-square distribution, first you should know what is normal variate and also standard normal variate. Okay, you already studied that. So suppose if we have x as a normal variate with mean mu and standard deviation sigma. Okay, here x is a normal variate with mean mu and standard deviation sigma. Then what is z, students? Z is a standard normal variate. How we define z? Z is nothing but x minus mu by sigma. Correct? We define z as x minus mu by sigma. Now this z is a standard normal variate. Clear, no? If x is a normal variate with mean mu and standard deviation sigma, then z is equal to x minus mu by sigma is a standard normal variate. Okay. So now this chi-square distribution is derived from the normal distribution. Okay, we'll see how it is related to each other. Okay. So now, as I said, z is a standard normal distribution or standard normal variate. Now this chi-square distribution is square of standard normal variate. That means if z is a standard normal variate, then square of standard normal variate is equal to x minus mu by sigma square is a chi-square variate with 1 degrees of freedom. Clear, no? What is chi-square variate? If z is a standard normal variate, then square of standard normal variate is called chi-square variate. That is, z square is a chi-square variate with 1 degrees of freedom. Okay. Suppose if I have two variables, that is z1 and z2. Okay. Here z1 and z2 are two independent. Okay. Two independent. Which variates, students? Those are standard normal variates. Here z1 and z2 are two independent standard normal variates. Now what is chi-square? Chi-square is z1 square plus z2 square. Correct? The sum of squares of standard normal variate follows which distribution? Chi-square distribution. Now since here only one variable, it has only 1 degrees of freedom. Since here we are having two variables, it follows chi-square with 2 degrees of freedom. Suppose again, if we have three variables, say z1, z2, z3. Okay. Here z1, z2, z3 are three independent standard normal variates. Then z1 square plus z2 square plus z3 square follows which distribution? Which follows chi-square distribution with how many degrees of freedom, students? Here we have three variables, so it follows chi-square with 3 degrees of freedom. It may ask for 2 marks, students. If z1 and z2 are two independent standard normal variates, then what is the distribution of z1 square plus z2 square or about three variables or any number of variables. So in general, if I write z1, z2, so on, zn are the n independent standard normal variates, then z1 square plus z2 square plus so on plus Zn square follows which distribution? Follows chi-square distribution with n degrees of freedom. Clear, no? This is the introduction part. So now we'll see what is the definition of chi-square distribution. Okay. The continuous probability distribution with the probability density function, that is PDF. So PDF is denoted as f of x, correct? No? So the discrete probability distributions are denoted as p of x, continuous distributions are denoted as f of x, correct? So f of x equal to k into e raised to minus chi square by 2 into chi square raised to n by 2 minus 1. Okay. So here the range is 0 less than or equal to chi square less than infinity. So this is f of chi square. Now this f of chi square is the PDF of chi-square distribution, and chi-square is known as the chi-square variate with n degrees of freedom. So how to define? So the continuous probability distribution with PDF f of chi-square equal to k into e raised to minus chi-square by 2 and chi-square raised to n by 2 minus 1 is a chi-square distribution with n degrees of freedom, and chi-square is known as chi-square variate with n degrees of freedom. Here k is a positive constant. Okay, so if you observe here, this chi-square takes only a non-negative values. Only non-negative values. Okay, so now chi-square with n degrees of freedom can be denoted as chi-square with n, as I said. So now if you observe this, see here. So what is the range of chi-square? It is from 0 to infinity and it takes only non-negative values. But I said this chi-square distribution is derived from normal distribution, correct? No? So what is the range of normal distribution? The range of normal distribution is from minus infinity to plus infinity. Then how it is the range of chi-square 0 to infinity? Yes, how it is? So what is the curve of normal distribution, which is bell-shaped curve? So symmetric above 0, minus infinity to plus infinity. Here like 1, 2, 3, so on. And here minus 1, minus 2, minus 3. So this is our normal curve. Okay. So how I define? If x is a normal variate, then z is a x minus mu by sigma is a standard normal variate, and what is chi-square? Chi-square is z square, x minus mu by sigma square. Okay, standard distribution is also have the range from minus infinity to plus infinity, correct? No? So for example, if z is equal to minus 1 and only, okay, z is equal to minus 1. So according to the definition, chi-square is nothing but square of standard normal variate. So that is minus 1 square means plus 1 agate. Similarly, if z is minus 2, what is chi-square? The square of standard normal variate. So minus 2 square means 4 agate. Similarly, if we take any negative values, the chi-square variate will get the positive values only, correct? No? So we will get the curve in positive side only. That's why the range is for chi-square is from 0 to infinity. It takes only a positive values, and curve for chi-square variate is only positive side. So and which is positively skewed also. So which is the curve of chi-square distribution. So now we will see some features of chi-square distribution. Okay, the first one. Here n is the parameter of chi-square distribution. Okay, the n is the parameter of chi-square distribution. Now, what about range, students? The range of chi-square distribution is range of chi-square distribution is from 0 to infinity. Then, third one. So, what is mean, variance, and standard deviation? So, for mean, for chi-square distribution, mean is equal to n, and variance is equal to 2n, and as we know, standard deviation is square root of variance, so which is equal to square root of 2n. Okay, so now fourth one, for a chi-square distribution, mode is equal to n minus 2 if n is greater than 2 and 0 if n is less than or equal to 2. Clear, no? The parameter of chi-square distribution is n. Range is from 0 to infinity. For chi-square distribution, mean is equal to n, variance is equal to 2n, and standard deviation is square root of 2n. And mode is n minus 2 if the value of n is greater than 2 and 0 if n less than or equal to 2. Then the total area under chi-square curve is equal to unity, that is 1. Then sixth one, this chi-square distribution is leptokurtic, and which is positively skewed, and one more is as n tends to infinity, or we can say when n is very large, chi-square distribution follows normal distribution. Chi-square distribution follows normal distribution. These are the important features of chi-square distribution. The parameter is n, range is 0 to infinity, mean is n, variance is 2n, and standard deviation is square root of 2n. And mode is n minus 2 if n greater than 2, 0 if n less than or equal to 2, and total area under chi-square curve is 1, and the chi-square distribution is leptokurtic and which is positively skewed, and when n is very large, chi-square distribution tends to normal distribution. Okay, this is about the features of chi-square distribution. So now we'll see what is the application part or the uses of chi-square distribution, where these chi-square distributions are used. So as we know, so the normal distributions are used to find whether the given population has the given mean or not, correct? No? Normal distribution is used to test the mean, correct? No? It may be a single population mean, the two population mean means whether the two population to test the difference between the two population means, correct? No? That is the uses of normal distribution. Now, what are the use of chi-square distribution? First one, to test whether given population, the population has given variance. So if we want to test about the population variance, then we have to use chi-square test. Then which is also used to test the goodness of fit of a theoretical distribution to the observed frequency distribution. And third one is to test the independence of attributes in a 2x2 contingency table. Okay, these are the three main applications or uses of chi-square distribution. The first one is to test whether the population has the given variance. ಹೇಗೆ ನಾವು ಮೀನ್ ಫೈಂಡ್ ಮಾಡಲಿಕ್ಕೆ ನಾರ್ಮಲ್ ಅಥವಾ ಟಿ ಟೆಸ್ಟ್ ಅನ್ನು ಹೇಗೆ ಯೂಸ್ ಮಾಡ್ತೇವೆ ಅದೇ ತರ if we want to test the population variance, then we should use this chi-square test. Then goodness of fit of a theoretical distribution to the observed frequency distribution. Then to test the independence of attributes in the 2 cross 2 contingency table. Okay. So this is about the chi-square distribution. So this chi-square distribution is derived from the normal distribution. If z is a standard normal variate, then square of that is that the square is a chi-square with 1 degrees of freedom. Correct? No? Then we have studied the definition, the features, and the application part. Okay. So in the next class, we'll see some basic problems based on the chi-square distribution.